Question number 28. Which one of the following will have the largest number of atoms? So we've been given four parts rather. So you have the first one having 1 gram of gold, second one has 1 gram of sodium, third has 1 gram of lithium, and fourth has 1 gram of chlorine molecule. So let's get to it. First of all, let's start with the first one. And the principle, the basic idea behind the first one will get followed for all of them. Okay. So the first one is 1 gram of gold. That is a solid. So in 1 gram of gold, how many will be the number of atoms? So from the basic idea of mole, we know that 197 grams of gold will have 6.022 into 10 to the power 23 atoms. This is because the Avogadro's number is equal to the gram atomic mass of that particular substance. So 197 grams of gold will have 6.022 into 10 to the power 23 atoms. Then 1 gram of gold will have how much? This is the basic crisscross method. So that is equal to 6.022 into 10 to the power 23. This will go here, right? And this will come to the denominator. So divided by 197. Okay, now because the same 6.0, that is that Avogadro's number will be applicable for all of them, we are not going to simplify our equation. Let's just leave it at this. Okay, now let's go to the second one. That is 1 gram of sodium, which is also a solid. So 1 gram of sodium will have how many atoms of sodium in it? We know that 23 grams of sodium will have 6.022 into 10 to the power 23 atoms. So 1 gram of sodium will have how much? That is done by 6.022 into 10 to the power 23 into 1. I'm not writing the 1 because 1 gram. Okay, so this will go to the numerator, divided by 23. Okay, so here you have grams and grams will get cancelled, leaving behind 6.022 into 10 to the power 23 divided by 23 atoms. So atoms. Okay, next, third one is 1 gram of lithium, which is also a solid. So in this case, the atomic mass of lithium is 7, right? So 7 grams of lithium has 6.022 into 10 to the power 23 atoms. So 1 gram of lithium will have how much? This is given by 6.022 into 10 to the power 23 divided by 7 atoms. And the fourth case, till here we had been given atoms, but in this case we've been given a molecule. So in this case we will be considering the gram molecular mass. So the gram molecular mass of chlorine is 71 grams. So 71 gram of chlorine will have 6.022 into 10 to the power 23. You guessed it, right? Because we are talking about the molecule, we will write 6.022 into 10 to the power 23 molecules. Okay, so then how many atoms will it have? One molecule of chlorine has 2 atoms. So 6.022 into 10 to the power 23 molecules will have 2 into 6.022 into 10 to the power 23 molecules. Atoms. So here we took the same relation, but because we are considering the atoms, the largest number of atoms, we are not concerned with the number of molecules, we are multiplying it and converting it to atoms. So 1 gram of Cl2 will have how many atoms? This is given by 2 into 6.022 into 10 to the power 23 divided by 71 atoms. And this is simplified to give us 6.022 into 10 to the power 23 divided by 35.5 atoms. So whichever number, okay, so first of all of the numerators are the same in all the 4 cases. So we need to consider the denominator. In simple terms, 1 by 2 is higher than 1 by 4, right? Because 1 by 2 is 0.5 and 1 by 4 is 4 ones are 4 2s are 0.25. So the higher is the numerator, higher is the denominator, less will be the value for the fraction. This is what we've learned in math. So here you have the numerator as the same for all the 4 cases. We will only consider the denominator. The one with the least denominator will have the highest value. So 7, that is lithium, because it has 7 on its denominator, the value when it gets simplified, the value will be the highest compared to all the other 3. That's why 1 gram of lithium has the highest number of atoms. So first you need to understand the basic idea behind mole concept. This is to do with mole concept. So 1 gram, 197 grams, that is the gram atomic mass of that element, will be equal to the number of atoms in that particular sample. So we have been asked for 1 gram. We just cross multiplied it and then we figured out. Here we didn't simplify because here we are comparing all the 4 and all of them will have the Avogadro's number, that is 6.022 into 10 to the power 23. So all the numerators are same, and so we just compared our denominators, and the one with the least denominator has the highest number of atoms present in it. Question number 29. Calculate the molarity of a solution of ethanol in water in which mole fraction of ethanol is 0.040 units of mole fraction is nothing, so no units. So we know that our solution has two substances, obviously the solute and the solvent. So our solute is ethanol. For ease, I am just going to write it as C2H5OH, and our solvent is water. So mole fraction is denoted by an X. So X of C2H5OH will be equal to the number of moles of C2H5OH divided by number of moles of C2H5OH plus the number of moles of H2O. So this is the basic formula behind the mole fraction. So now we need to, for molarity, as we know, we need to calculate how many moles of ethanol is present in 1 liter of the solution. So moles of C2H5OH in 1 liter of the solution. Okay, but we know that it's nearly dilute because the solution is almost very dilute. Because of that, moles of C2H5OH in nearly 1 liter of water, because this solution is extremely dilute. So the number of moles of H2O in 1 liter of, number of moles of H2O in 1 liter of water equals to 1000, because we are taking 1 liter, divided by 18. That is the molar mass. So that is equal to 55.55 moles, because here we are taking the number of moles of water in 1 liter, because this way we are able to calculate the number of moles of water, and we are assuming that because the number of moles of ethanol is very less, because the mole fraction is very less, so the solution is basically quite dilute. So number of moles of water in 1 liter is 55.55 moles. Now we will be substituting all of this in this equation. So N of C2H5OH divided by N of C2H5OH, that is ethanol, plus 55.55 moles, and that is equal to 0.040. Next we will be multiplying these two. So when we multiply, we get N of C2H5OH equals to 0.040 of NC2H5OH plus, because this when it comes over here, I'm just basically we are multiplying this with this and this, and so plus 2.222. So when this goes to this side, becomes minus, and so this becomes equal to 0.96 N of C2H5OH equals to 2.222 moles. Right, so when we simplify this further, we get N equals to N of C2H5OH equals to 2.222 divided by 0.96. So when this is simplified, we get 2.31. So the number of moles of ethanol is 2.31. So 2.31 moles of ethanol is in 1 liter of water, or 1 liter of the solution. Okay, so the molarity will be equal to 2.31 mole. So here we had to calculate the molarity of a solution of ethanol in water, and mole fraction of ethanol is given. So the basic relation is mole fraction of ethanol equals to number of moles of ethanol divided by total number of moles in the solution. So the number of moles of ethanol is present we need to calculate in 1 liter of the solution, or nearly completely dilute solution of ethanol in water. So we calculated the number of moles of number of moles of water in 1 liter of the solution of 1 liter of water, because it's nearly dilute. We are just calculating the number of moles. And then from that we substituted these values in the equation, simplified it, and we got the number of moles of ethanol as 2.31. So if 2.31 moles of ethanol is present in 1 liter of the solution, which means the molarity automatically is 2.31, because that is the definition of molarity. Question number 30. What will be the mass of one carbon-12 atom in grams? So this is also related to the mole concept. So 1 mole of C12 will have 6.022 into 10 to the power 23 atoms, and this is equal to 12 grams, because the number of 6.022 into 10 to the power 23 atoms of that particular element is equal to its gram atomic mass. So 6.022 into 10 to the power 23 atoms of C12 has 12 grams. Then one atom will have how much? So if one atom, it will be how much? So one atom of C12 will have, it's supposed to be here, will have mass equals to 12 here. So cross multiplication, 6.022 into 10 to the power 23 grams. So when this is simplified, we get 1.9927 into 10 to the power minus 23 grams. So here we use the basic relation of 1 mole of that particular atom will be equal to 6.022 into 10 to the power 23 atoms, which is equal to the gram atomic mass of that particular atom. So we know that 6.022 into 10 to the power 23 atoms will have 12 grams as its mass. Then one atom will have how much? This is a simple cross multiplication question. So we just simplified it and we got the mass of one atom is 1.9927 into 10 to the power minus 23 grams.